So experiment 10 is on synchronous motor. So we will be using the same panel on which we conducted the experiment number 9. So this is your DC machine and this is your synchronous machine. So your experiment is on this synchronous machine which will be acting as a synchronous motor. So our objective is to synchronize the synchronous machine with the bus bar and to conduct load test, and then we plot the V curve. V curve will be plotted between IF and IA. So this is your DC shunt motor. This you will use as a DC shunt motor, and this initially it will work as a synchronous generator. After synchronization, this will become synchronous motor and this will become DC shunt generator. So once again I will repeat, before synchronization this machine will work as a DC shunt motor and this machine will work as a synchronous generator, alternator, you can say alternator, 3-phase alternator. And after synchronization we will put this switch off, then this machine will become DC shunt generator and this machine will become as a 3-phase, this machine will work as a motor, synchronous motor. It will be running at synchronous speed. So this is your experimental panel on which you will conduct the experiment. So this part of the panel is DC shunt motor connections. This side is DC machine connections. Here is the DC supply, 220 volt DC supply switch. Terminals are here plus minus, and these are the terminals for making the connection of DC shunt motor and starter connection. Starter points are L, A, F, and DC machine armature terminals A1, A2 and field terminals Z1, Z2. And this is your DC supply, 220 volt DC, and when you will put this switch on, the supply will be available across these two terminals, that is plus minus. And this part of the machine is synchronous machine part. Here synchronous machine A1, B1, C1 are the three terminals of synchronous machine, and armature terminals of synchronous machine A1, B1, C1, and X1, X2 are exciter terminal of the synchronous machine, exciter or field we can say. So exciter supply is given through this switch. This is the switch for giving the supply to exciter, and so when we will put this switch on, supply will be available across these two terminals, and that is connected to the exciter through rheostat and ammeter, and this ammeter is connected to measure IA. This will give you the IA. It is connected in the alternator side, IA, and this ammeter will give you IF, the exciter current, field current you can say. So IF and IA, you will take these two reading and also will take some other readings also will be taking. So here these two are the machines on which we will conduct the experiment. So this is your DC motor which we will use in this experiment as a motor as well as generator. So you can see the nameplate rating here, that is your DC shunt motor, and here are the 4 terminals, 2 terminal of the field and 2 terminal of the armature. Then another machine coupled to this DC motor is alternator, that is 3-phase alternator or 3-phase synchronous machine, same thing. So this is the nameplate rating of alternator or 3-phase synchronous machine. Here you can see there are 6 terminals, 2 terminal of the field winding, 3 terminals of the armature terminal, and 1 is the neutral. Please make sure this machine is star connected. So we have neutral point also. So our experiment is on, actually our experiment is on this machine, which we will be using initially as a generator, and then it will work as a motor. So after making this machine as a motor, then we will take the readings. So now we will make the connections. So I will show you the connections first of the motor side. This DC machine connection I will show you one by one. That is, the positive end of the supply is going to L, and A end of the supply is going to A1, and F, actually this is the 3-point starter. It has 3 terminals, L, A and F. So L is connected to the positive, A is connected to the rheostat, and that is going to the Z1, and the A terminal of the 3-point starter is going to A1, and then A2 and Z2 are joined together, which is going to the negative end of the supply. And this is the load connected to the machine. So this load is connected across armature terminals A1, A2. The load is connected across A1, A2. So you can see here two connections are going. One, this end is connected to A2 and the other end is going to A1. That is going to the load. This is the resistive load, and one ammeter is connected to measure the current and one voltmeter is connected. So I will show you these connections. This is the DPST switch. So initially we will keep this switch off and make sure this rheostat should be at minimum position, which is connected in the field circuit of motor. So as I told you earlier, the motor field circuit rheostat is always kept at minimum position before switching on the supply, and the field circuit rheostat of the generator will be at maximum position. So this is connected in the exciter of alternator. So initially, which is working as a 3-phase generator. So this rheostat you have to keep at maximum position before switching on. So you can see here, this rheostat is at maximum position. So we are using this terminal and this terminal. So it is maximum position, and this rheostat is at minimum position. So first we will start to make the connection from positive. So positive end of the supply is going to L, then A is going to A1, this is A is going to A1, then F terminal is going to the rheostat, here rheostat, and rheostat other end is going to the Z1, and A2 and Z2 they are joined together, and that is going to the negative end of the supply. You can see this wire is going to the negative. A2, Z2 are joined, and that is going to the negative end of the supply. Then load is connected across A1, A2. So these two terminals you have to use for connecting the load. So you can see here, these two terminals are going first to the switch. So these two are connected to the switch. The name of this switch is DPST switch, and output of the switch, one is connected directly to the load, and the other end of the switch is going to the ammeter, and ammeter to the load. So this will give you the load current, and this is the voltage across the armature terminal. So this voltmeter is connected across the armature terminal of DC machine. So this side is DC machine connection, and this side is synchronous machine connections. Remaining part of the experiment is already wired, permanently wired, like this voltmeter, this frequency meter, these lamps, and synchronoscope. They are permanently wired. So this synchronoscope, this is the synchronoscope. This is the synchronoscope. This is synchronoscope, and these are the 6 lamps. 2 lamps are connected in series. So in one, there are 3 phases. So in one phase, 2 lamps are connected in series. So 3 phase, so we have total 6 lamps connected. And then we have this switch, DP-DT switch. This side, if we will keep this switch on the machine side, this voltmeter and frequency meter will read the voltage and frequency of machine, that is of the synchronous machine. If we will keep this switch to this side, bus bar side, then it will read the frequency and voltage of the bus bar. Bus bar means supply voltage. The electricity board, the supply which is coming from the electricity board. So this will read the bus bar, supply, frequency and voltage. So this part is already wired. You don't have to connect anything externally. So now we will make the connection for synchronous machine, this side connections. So here we will be connecting this supply is going through the switch to ammeter. So plus terminal of the plus end of the supply is going to ammeter to rheostat, and rheostat to X1, and the negative is going to X2. So we'll make this connection, and also we'll connect this ammeter in between R1 R2 in this line. So 2 terminals are there on the panel, R1 R2. In between R1 R2 we will connect this ammeter. Remaining part of the circuit is wired, means this synchronizing switch, these lamps, this voltmeter and frequency meter, these are already wired. You don't have to connect externally, they are already wired on the panel. So these two are the terminals of supply, plus minus, and this is the switch. So on position and off position. So keep this switch off and then connect positive end of the supply to rheostat and rheostat to ammeter and ammeter to X1. We'll make the connections like this. Then you will connect this ammeter, which is AC ammeter, between R1 R2. There are two terminals R1 R2 which is connected in the R phase of supply. So this ammeter will give you the R phase current, or you can say the line current. So this ammeter, which is AC, is connected between R1 R2, and this will give you the IF, which is DC current, DC ammeter, and this is AC ammeter, which will give the IA. So IF, IA, and this is your load current and voltage across the load. So you will be noting 4 observations: IF, IA, this is the IL, load current, and VL, voltage across load. Now our connections are ready. So before switching on, as I told you, this rheostat will be at minimum position and this rheostat will be at maximum position. Now switch on the supply and start the DC motor with the help of 3-point starter. So now our DC motor is running. After this we will switch on the excitation. Now we can see the bulbs. You can see the bulbs. So they are rotating in very fast in anti-clockwise direction. You can see this is your synchronoscope. So this light is running anti-clockwise and these bulbs are also flickering in anti-clockwise direction. So before synchronizing, we have to check 3 things. Phase sequence. Phase sequence means the phase sequence, that is R, Y, B of the bus bar should be same as that of synchronous machine. So this is the R, Y, B. Here name is given A1, B1, C1. So this phase sequence and this phase sequence means the phase sequence of the bus bar should be same as that of the synchronous machine. Second thing is you have to check the voltage and frequency. So phase sequence already we have matched, that you don't have to check anything. The phase sequence is already we have checked and it is matched. So now we have to check the voltage and frequency of machine and the bus bar, and we have to make them equal. So first we will check the bus bar frequency and voltage. So you can see bus bar, so you can see here bus bar means the supply voltage, supply which is coming from the electricity board. So the voltage is 402 volt and frequency is 49.93. So you have to make these two voltage and frequency same as that of the bus bar, means this machine voltage and frequency should be same as that of the bus bar. So this voltage was 402 and frequency was 49.9. So you will increase the frequency using this rheostat. So as you will increase the resistance, the speed will increase, and you can see here this frequency will increase. You can see the frequency is increasing. So also you can see when the frequency is increasing, it means it is coming close to the bus bar frequency. This rate of flickering is also, now it is this light is rotating slowly. Earlier it was rotating very fast. So you have to increase further and make this flickering very slow. When the frequency of machine and bus bar is equal, this flickering will be very slow. You can see here. Now this is rotating very slowly. So frequency, now it is 49.78. Now we'll check the voltage. That was 402 volt. That was 402 and 49.99. So see the machine frequency, that is 49.89 and voltage is 180 volts. So you have increase the voltage. The voltage we will increase using this rheostat. So decrease this resistance. So what will happen when you will decrease this? When you will decrease this, this voltage will increase. So you can see the voltage. I am decreasing the resistance. So you can see here the voltage is increasing. You have to make this voltage to 402 volt. Now the voltage is almost same, 402 volt, and frequency is 49.73. So we'll make the frequency same, 49.9. So now the frequency is almost same. So this is the condition when we are making the bus bar and voltage, the bus bar frequency voltage and machine voltage and frequency are same. So now you can see the rate of flickering. Now the light is rotating very slowly. So this is the synchronizing switch. This switch is to be closed when this L1 is off, L2 and L3 are equilibrate. Means these two lamps are off and these four bulbs are equilibrate. At that moment you have to close the synchronizing switch. Or you can say when this green LED light is glowing, at that particular moment only you have to close the synchronizing switch. So you hold the synchronizing switch, and close when this green light is on. So now you can see the machine is synchronized with the bus bar. So L1 is off. Actually these L1, L2 are in series. So they are off. L2, L3, two lamps are connected in one phase. Means in R phase, L1, these two lamps are connected in series. In Y phase, L2, these two lamps are connected, and B phase, these two lamps are connected. Now machine is synchronized with the bus bar. So these two lamps are dark and other four are equilibrate. So one part of the experiment is complete, that is to synchronize the synchronous machine with the bus bar. Now machine is synchronized with the bus bar and it is floating on the bus bar. So after the next step is you have to put this supply off, DC supply off. After putting this supply off, this machine, it means DC machine will work as a DC generator and synchronous machine is work as a synchronous motor. Before synchronization, when this switch was on, and this is off, at that time this machine was working as a DC shunt motor and this was working as a synchronous generator. After synchronization, when we will put this switch off, this will become DC shunt generator and this will work as a synchronous motor. Now our next part of the experiment is to conduct load test and plot V curve. So for that purpose we will switch on the load. Now you can see the voltage is 220 and current is 0. So I will increase this current to approximately 5 ampere. So I will put this switch on so that our ammeter current is, means load current is approximately, so you can see here this current is now 5.12, but voltage is dropped, it is now 209. It is 209, but the rated voltage of DC machine is 220 volt. So you have to set this to 220 volt by using this rheostat. So you can see, so you have to decrease the resistance. So as I am decreasing, this voltage is increasing. So you can see here I am decreasing this voltage is increasing. So you have to set this to 220 volt. So now you can see the voltage is 220. The voltage is 220 and the current is 5.4 ampere. So now we will note down the readings. We will note down the reading, that is voltage across the load is VL, that is 220 volt, and this is the armature current of DC shunt generator. DC shunt generator, or you can say the load current. So we will note down these two readings, and then we will take the reading of IF and IA to plot the V curve. Or so we will see here. So now we will take the reading of IF and IA. So these two are the readings of synchronous motor. So this is IF, exciter current of synchronous machine, and this is IA of synchronous machine, and this is the IA of DC generator, and this is the voltage across load. So these two will be fixed, 220 volt, 5.4. That will not be varying now. Now as you will vary this IF, this IA will vary. So now I am keeping this rheostat at minimum position, means resistance is not there in the field circuit exciter. In this circuit, this resistance is minimum position. So this is the IA maximum value. IA maximum value is 5.8 and IF is 0.798. That is your first reading. For next reading, you will increase the resistance. Randomly you can increase, and then you can note down the readings. You can see here IF is decreased, IA is decreased. Note down the reading, and then for next reading again increase the resistance. So you will observe here IF is decreased, IA is also decreased. Again note down the reading, and then again further increase the resistance. So now you can see here IF is decreased, but IA is now increasing. Now it is IA is increasing. So first power factor is lagging, unity and leading. So first this IA will decrease, it will be minimum, and then it will increase with the IF. But IF will be, every step it will be decreasing only. So note down the reading, and for next reading again decrease the resistance. So you can see here IF is decreased, IA is now increasing. So this we will get the V curve reading. So we will keep this decreasing resistance in steps one by one and note down the readings. So last reading we will take when this resistance is almost at maximum position. So now you can see here this resistance is almost fully included, maximum position. So that is your last reading, which is 0.191 IF and IA is 5.26. So this way we will take the reading of IF and IA and plot the V curve.